The second example, Renault number similarity model test to be performed to study the flow through a large check valve having 0.1 diameter inlet and carrying water at the flow rate of the 0.85 cubic meter per second. The working fluid in the model is water at the same temperature as that in the prototype. So we use the same fluid, the same as the model prototype is water. Compute the geometric similarity exists between the model and prototype, and model inlet diameter is 7.5 centimeter. Determine the required flow rate in the model. Okay. So given that this is a check valve and given the diameter of the prototype, the Q of the prototype, and the diameter of the model, and what is the flow rate for the model. Okay. And we apply the dynamic similarity. The Reynolds number between model equal to Reynolds number of the prototype. So this is the equation for the Reynolds number. And because assumption is we use the same fluid, so the mu of the model equal to the mu of the prototype because it's the same, it's a water. So we can write the ratio between a velocity model and prototype model based on equal to the ratio of diameter. And the next, if we apply the Q equal to VA, okay, to compare the Q of the model and prototype, so is equal to V model area equal divided by V prototype area prototype. And for we substitute the ratio of Vm and V equal to D divided dm. Okay, for the ratio, and for the area is equal to pi over 4 pi over divided by 4 dm square divided. Okay, so we got the dm divided by d. Okay, so in this we can estimate what is the Q for the model equal to the ratio of diameter of model 7.5 cent divided by 0.6 centimeter and times the Q of the prototype. So we got for the model is equal to 0.106 cubic meter per second. So in this case, we know that we use the same fluid. Okay, if we use the different fluid, so okay, we use the same fluid, and we check the velocity of the flow velocity, whether it's possible to test in the labs. Okay, the ratio of the V model of compared to the V prototype equal to, from above is a reverse of dm over d. And in this case, dm over d is 7.5 compared to the 60 centimeters, so it's about 0.125. And for velocity for the prototype is equal to is about 3 meters per second for the prototype. And if we check for the model is equal to 0.015 power minus 1 and times 3, so it's about 24 meters per second. Okay, but in this case it's a high velocity, but it still it could be attained in a lapse. But if we use the dm is smaller for compared to s, so let's say smaller from 7.5 to 2.5 centimeter, we can prove that the velocity for the model is 72 meter per second. So that is not possible in the lab to increase the velocity to 72 meter per second in the lab. So we conclusion that to maintain maintaining Reynolds number similarity Vm may be impractical to obtain. In this case, if the diameter is too small, 2.5 centimeters, so Vm is very large.